Draw the ray diagram of an astronomical telescope showing image formation in the normal adjustment position. Write the expression for its magnifying power. Okay, first we need to know where we are going to use this astronomical telescope. The astronomical telescope, we are going to use it for observing distinct image of heavenly bodies like stars, planet, and so on. Okay, how this will be work, we'll see with the help of a ray diagram. See, this is the diagram. Here we are going to use the two different lens. This is the first one is the objective lens and second one is the eyepiece lens. Okay, and this is the parallel ray at infinity. That means this is the parallel ray at infinity. That means this is the rays which is coming from the heavily infinite distance from the object. Okay, parallel ray at infinity. When it passes through the objective lens, it will be reflected in this direction through the eyepiece lens. Okay, at this point. And these are the different light rays. Okay, and the one more parallel ray is from the center of the objective lens, and it is also falls and in this point where these 2 points are meet each other. This is the image. Okay, and this image is the we are going to reflect for the eyepiece image. Okay, and this we call it the A dash and the B dash. This is the focal distance. F naught is the focal distance from the objective lens to the where the image is formed. And when this is reflected on the eyepiece in this point, and it will move in this particular direction and this direction we can see here. Okay, this is the image at infinity. This image, this where it is false here, this is the image at infinity point. Okay, and the magnification is given by, here the magnification is equal to F naught divided by Fe, or we can write this one as M is equal to beta divided by alpha. That means here the angle between these two, the coaxial, where these two lenses are placed on the axis, that coaxial, from that line to the image, that is the light rays falls here, this is the alpha angle, and where it is reflected from the eyepiece to the coaxial line, this is the beta angle. And we call this angle, this is the magnification, beta divided by alpha is the magnification. Draw a labeled ray diagram to show image formation by a compound microscope and write the expression for its resolving power. Okay, we'll see the label diagram of the compound microscope. This is the diagram. Here we are going to use two different lenses. One is the objective lens and second one is the eyepiece lens. Okay, these two are the coaxial, that means on the same axis these two lenses are placed. And this is placed over the microscopic tube and the distance is d. That means from this point to the eyepiece length, the distance is d here. Okay, here one object is there. That object length is AB. It is denoted by the H. Length is H here. Okay, from the point A, the object is parallel to the coaxial of these two lenses is move over like this. And it is reflected over the on eyepiece in this particular point. And from the same point, the same light will be passed over the center of the objective lens and is moving in this particular direction. It will be fall over here on the eyepiece. When it is exactly meet here, this is the image of the eyepiece image. This is the one of the image. We can see that one in the eyepiece image. Okay. See the length of the object here and the length of the object over here. It is gradually increases here. And this image will be move over in this direction. And it is also moving in this direction. Where it is these 2 points will be meet. Okay. This is the A dash, A double dash and B double dash. and at this point it is A dash and B dash. And the resolving power is given by resolving power is equal to 2n sine beta divided by 1.22 lambda. Okay, and here if you are going to observe here, the angle between these, this is the angle beta. That means from this point to here, whatever the angle is there, this is the angle beta here.